Okay, go ahead and write this down. So anyways, we have our equation, and then we have T1 plus T2 equals 60, and then they tell us R1 is 3 and R2 is 6. Okay, so I would start by writing down R1 T1 equals R2 T2. And then I would plug these in, like R1 is 3. So underneath R1, I'm going to replace it with 3. R2 is 6. And so underneath R2, I'm going to plug in 6. Okay? Because that's what those are equal to. Now I can pick which t to solve for. It does not matter which one, but you do need to get one of these t's by itself, okay? So I am going to subtract t2 from both sides. That way t1 is by itself, okay? So t1, if I rewrite this, which you don't have to, but t1 is equal to 60 minus t2. So I'm going to replace T1, I'm going to write really small so I can fit it in, is 60 minus T2. And then I leave this T2 in the equation. Okay, so pick either variable and get it by itself and plug in the one that you got by itself. All right, and now we're just going to solve. So what is 3 times 60? 180. And then 3 times negative 2t is negative 3 T2, and then this would be 6 T2. All right, we want to get all of our T2s together, so I'm going to add 3 T2, and I'm going to add 3 T2. So now I have 180 equals 9 T2, and then I'm going to divide both sides by 9, and we get 20 for T2. Okay, you need to find anything that's missing. We know R1 and R2, but we need to go back, hold on, and plug in for T1. The best place to plug in for T1 is where you isolated it. So we're going to do 60 minus 20. So T1 is equal to 40. So just find anything that's missing. Yeah. Okay. Okay, let's try another one. ROTO equals RSTS plus 16. So I would start by writing this down. Okay, and then I would plug in what I know, like TO is 8. Okay, so I'm going to, underneath the TO, I'm going to plug in an 8. And then TS is 4. Don't forget your equal sign. And I'm going to plug the 4 in for TS. We still have this plus 16. All right, and then again, this equation here, you have to do one step to isolate either the RO or the RS. Let's say I isolate the RO. That means I would subtract RS from both sides. So it would cancel here, which means that RO is equal to -1 minus RS. And then I would plug in. So if this is RO, I'm going to replace it with -1 minus RS. And then I need to rewrite the RS on this side. Okay, be sure you use parentheses when you plug in, because this 8 has to distribute to each thing here. So 8 times -1 is -8. 8 times -RS is -8 RS. I like to put the 4 in front here. This is 4 RS plus 16. Okay, then we need all of our RS's on one side, our numbers on the other. So I'm going to add 8 RS. And I'm going to add 8 RS here. And I'm going to subtract 16. So that gives me -24. And on this side, I get 12 RS. And I'm going to divide by 12 on both sides. So RS is -2. All right, and then you need to find RO. So if you go back and you plug in, you have -1 minus -2. That's going to make it a +2. So -1 plus 2 is 1. So RO is 1. Okay. And that's that. Everybody feel good about substituting? Okay. It's pretty easy. All right, vertical line test. Okay, we like are really interested if things are functions, right? And so far I was gone this day, but you guys watched the video last week when I was absent, or whenever this was, a couple weeks ago. All right, and anytime there was one input that went to 2 outputs, it was not a function, okay? So if I plug in 1 and I get 2, and then later on I plug in 1 and I get 3, not a function. I can't plug in the 1 and get 2 different outputs, okay? That's when it's not a function. So we can also do this with what's called the vertical line test, okay? So let's say our function is this beautiful circle, and they're like, is this a function, okay? We do what's called the vertical line test. Now, you can draw your line anywhere, and if it hits the graph more than once, it is not a function. If it only touches once, it's a function, okay? And that line you could put anywhere. So make sure you're checking, like, if I hit it twice at any time, and I draw a vertical line going this way, that's a problem. That's not a function, okay? Let's try another one. Okay, do we have a function? These are different graphs. Let's look at this guy right here. Whoop, whoop, whoop. All right, so you're picturing drawing a vertical line, meaning like it just goes straight down. How many times does it touch the graph here? Once. Okay, even if I draw the vertical line here, how many times does it hit? Oh, I moved it. Once. It's only going to hit one time, no matter where you draw the line. So this one is a function. Okay. How about this heart? Is it a function? No. How many times are you going to hit the line or the graph? Twice. All right. We have two outputs for one input. Not a function. Heart graphs, not functions. Okay. These are so big. Okay. All right, how about this sideways parabola? How many times will a vertical line hit the graph? So is it a function? No. How many times will your vertical line hit this graph? Once. So this is a function. Okay. All right, let's try some whiteboards. That was it. That's called the vertical line test, by the way. All right.